Okay, so today is May 12th, and today we have I guess it's a medium question. And today I don't know if LeetCode figure out that they need to let people know how many time travel ticket that they use. So today they actually marked uh the time travel ticket in a different color. So if you check my week 1, everything is on time. And then my week 2, there shows there are 3 days that I kept using the time travel ticket. So I believe a month you can only use total of 3 time travel ticket in a month. So for the next 3 weeks of May, include today, I cannot use any time travel ticket. Otherwise, I won't get the badge, I believe, for May. So yeah, somehow today they add this, and that's good. That's a reminder for me that I have to do this earlier so that I won't use any more time travel ticket ever again for May. Okay, so hopefully we can solve today's issue without like using the time travel ticket. And let's take a look at the today's question, which is 304. Range sum query 2D immutable, and it's a medium question, have 1700 upload. So this is definitely something that we need to learn, and we need to make sure that we know how to do it. And do we have a hint? We don't. Okay, but since it's immutable, I think this should be pretty easy. It should be just a prefix sum problem, right? I think although it's 2D, we already know how to do it in one dimensional. So now that's two dimensional, let's see if we can use the same technique to solve this. And then I guess if we could solve this, there should be a day that we need to try to solve the range sum query 2D mutable, which might be able to solve with binary index tree or segment tree, but I don't know about that yet. So let's see first if we can solve this today's problem, the immutable range sum query 2D. Okay, so let's start reading the today's question. So you are given a 2D matrix. Handle multiple query of the following type. Calculate the sum of the element of matrix inside the rectangle defined by its upper left and lower right. So implement the num matrix class. So this class, this method, I forgot how to call it. So initialize the object with the integer array matrix, and the sum region you got 2 points, so I believe it's one is upper left, the other one is lower right. So what are those colors? Okay, oh, those colors are the input query. So let's see. So your function code is constructor and some region, some region, some region. So the constructor pass you this entire array, and then your some region is calling with 2143. 1122 and 1224. So 2143 is 2121 is this one, and then 4 1 2 3 4 1 2 3. Okay, so the first query is the red one. The second query, I believe, is the green one, 1122. The third query is the blue one. So we have to have a method that can handle multiple query of a 2D range sum. So I guess that's it. And the constraint is mn. So the metric is less than 200 times 200. And the element inside it is from negative 10 to the 5 to positive 10 to the 5. And row 1, row 2, your input will be in the range, so you don't need to worry about out of range. And you will get at most 10 to the 4 costs to the sum region. Okay, so like we already know, for the 1D we use the prefix sum, right? So for the 2D, I'm thinking about the same. So I think we can like do a prefix sum for each row, right? And then for that, after that, we then do the prefix sum for each column. So then that matrix will represent, for example, if we choose this 0 in here, it will represent, can I draw? Let me check. Okay. It will represent what? I cannot guess. Okay, so from here, so if we choose this 3, then that matrix will have the total sum of this. So now if we want to say that we want to find we want to find this. So if you want to find this, then we can take the range sum of can I change color? The range sum of this and minus another color minus this. Why can I use this color? Oh, I don't have a lot of color to choose from. So this and this. And then add back probably this. I don't even know what I'm drawing. Okay, anyway, yeah, so what I'm trying to do is just prefix sum on a 2D. So let's try it. First we do, so when we have the constructor, I don't think we need to keep the original matrix, right? So we only need to do a integer and a prefix. So then when we have this, we prefix equals to new to matrix dot length and matrix 0 dot length. I can do this because it's at least 1. And then Do I want to declare this so that it's easier for me to code? Yeah, maybe. Why not? Let's just follow the constraint. Or maybe no, that's fine. M N. So it's probably easier for me to read. Okay, so then this will be M, and this will be N. Okay, so now let's do the prefix for sum first, right? So like for each row, M. So for each row, and then for each prefix, like row, and the first column is always equals to matrix the row and the column, right? And then hello. It's not too crazy, but still I'm not sure. Yeah, I hope my thought is correct by doing the prefix sum. Yeah, so let's try it. But I code really slow though. So where was I? Yeah, okay. So I'm doing this, and then for int I have a typo. J equals to 1, j smaller than n, and then j plus plus, and then so we then start sum up this prefix like this row, and the j will equals to the previous one, which is, let me, so that I don't have typo, so the same row, the previous one, plus matrix I and j. Okay, so I guess that's for our prefix sum for each row, right? And after we've done this, then we maybe like do the prefix sum for each column, so that we can get the each square size, I mean square sum from the 0 to that point. Okay, so after this is done, then for each column, so now we are doing the column. Do I want to keep using j for column? Maybe. J is smaller than, so column is n, j plus plus, and now so we already have the first, so now we do the int I equals to 1, I smaller than equal to m, I plus plus, and then we are going to do the prefix, so previous row current column equals to what? So we are keep, So wait, I'm doing this correctly? Hey, hello. So you are just adding up your previous one, right? This is that. Okay, I don't know why you are green, because I guess that's the screen overlay for the string lab. Okay. Yeah, so it's just keep adding up, right? Is that correct? Is that correct? This is that, and this is that, and this is that. So that's for the constructor, right? I think. And then once we get a query, for example, when we get this, then we have the prefix sum for the bigger one minus, so we need to know like this and this and this. Okay, so for this we are returning like the prefix of so this is top right, this is lower left, right? So we are using this, right? So it's this one minus, oh no, so minus the same. For example, for this one we are going to minus this, right? So I want to get this. So what is the number? So this is row column, so this is row 1 minus 1, right? Okay, so this is row 1 minus 1, and the same column, right? Column 2. But that's only when row is, if row equals to 0. God, I'm confused myself. If then 0, otherwise this, right? And then we minus another thing, which is so then we minus this. So what is this? So this is the same column as column 2, but row 1, hold on, okay, the same row with row 2, so the same row with row 2, but the same column as column 1 minus 1, right? So we need column 1 minus 1. So am I confusing myself? Okay, now we need to plus this one, right? So this one is only needed when we have both column 1 and column 2 larger than 1. So now we plus, so So if they are both 0, then 0, right? Otherwise, we have this and this. Am I right? I don't even know. Because there's no hint. So I hope it's right. But I got compile error. Line 6. Oh god. Okay, not too bad. How many test cases we have? We only have one test case. So is there any like edge cases? I guess not. Let's try it. So what if I only, they can't have empty, right? So maybe for this, let's call it one more time. Let's call it twice. So what if I want to have from here to like 0, 1, 2, 3, 3, 0. And what if I want like 0, 0, 0, 0. And then for this, can I do can I do an array that is only one element? And then for this one element, I probably can only do one query, which is 0, 0, 0, 0, which I probably already test. Invalid test case. R invalid expect row 2 to have value. I have 1, 2 more. No, I think that's this right. Ah, okay, so is this right? Okay, I did something wrong in here. Oh, I can only have from 3 to, so I cannot do 3, 0. Which one is wrong? I don't even know. Okay, anyway, I can't figure out what's wrong with the test case. 2, 1, 1, 2, 2, 1, 2. Did I put something wrong? Anyway, let's try submit it. No, array out of bound. So now if I have this, so it's out of bound in 22. Yeah, okay. Oh, shoot. Yeah, why I put end in there? God. Should have test more. Okay. So now that's it. And I didn't, yeah, because I already used 3 time travel, so it's good that we have made this question. So let's check the solution. Brute force TLE, caching MLE, caching rows, caching smarter. So is the caching smarter the two-way caching that we are doing, the prefix sum? Why everybody's code is shorter than mine? I mean, mine is way longer, so yeah. Yeah, because like all the other dynamic programming, you can just give one more when you declare the DP array so that, yeah, you don't need to deal with the case in the edge. Okay, lesson learned, lesson learned. I always forgot this. I always forgot by doing this, I could make the code shorter, because every time I do this, I will confuse myself about the initial case for all the zero part. So yeah, I try to not do this. And I guess everybody's, can you go through the explanation? Okay, hold on. I guess if you want to know, hey, where is my code? Okay. So you probably need to know the range sum query. Do we have a 1D in here? Similar question. Yeah, immutable. This one, I think. Yeah, so you first learn this by doing a prefix sum, right? So have I do this before? Yes, I did this. So the range query is for 1D array, the range query is that you have a prefix sum array. So the zero element is the zero element, and then the first element is the sum until this point. So it's a sum from these two, and then the third element is the sum of this, right? So if you have, so that's called prefix sum array. So for one dimension, first thing you do is that, so you have an integer of prefix sum. So you have an integer array of prefix sum. So when you got the input, then you just declare this first. Right? So then for, and then I guess prefix sum, their first element is the same. And from the second element to the end, it's the sum of the each element, right? So for int I equals to 1, I smaller than star length I plus plus, and prefix sum I equals to nums I plus this. So after doing so, if your original array is like this, then this is num. Then you will have your prefix like this. So first one at first, second one is this, and then second one at this one is 1, and 1 at -5 is -4, and then -4 at 2 is -2, and -2 add this is -3. Yeah. So now if I want to have the sum of this range, like from the 0, 1, 2, if I want the sum from index 2 to index 4, if I want the sum of this, if I want the sum for this, this sum will be the sum from this minus the sum from here, right? So it's actually the sum from, or the sum, I should use this. If you want a sum for this 3 element, then it will be the sum for this element minus the sum for this 2. Sum of this, sum of this, right? So, and now this is the one that we want, and then this where you know, right? So this sum of this array is in here, right? So this will be -2 minus this sum is here, right? Minus -2. So this is for 1D, and then you just use the same idea to do 2D. So that's why you first see me. Is this considered dynamic programming? This is sort of, that's why you see that, you see the solution is calling itself DP, right? So it's sort of a dynamic programming that you actually break it down to a smaller problem, right? So for this 1D, you break down this problem to some pre-compute number. So yes, this is sort of like dynamic programming. But usually I think this is called prefix sum. So that's why I call it prefix sum. So this technique is usually called prefix sum. Although it's dynamic programming, but this has a special name called prefix sum. So that's why you see all the similar one are those. So it's always ask you for a sum range. Yeah. So for this, and this is usually to resolve the issue that you have the same array, but then you got the query several times, and to avoid recalculating those several times, you create a dynamic programming array and pre-compute all the answer, and then just quickly get the query. So once over array to get a sum for each index, then each lookup for sum. Yes, yes, yeah. So you only inside the constructor you spend most of the time doing the calculation. Once it's done, you can handle as much as the query you got. So yeah, usually, yeah, although this DP, but usually this called prefix sum. So, and if you see there is some related problem, so for example, this is immutable, which means that once you are given the input array, it cannot be changed, right? So the 2D case look like principle of the inclusion. Yes, yes, yeah. Just it's called, probably in math it's like set theories, right? So the intersection of two set is, or the union of two set is this plus that minus the intersection. Yeah, so you use that to solve the 2D. Yeah, so after you are pretty comfortable with this, with a range sum query for the immutable, then you can try the range sum query 1D mutable. Although this is, I think this is still a medium question. I think this is a medium. Yeah, although this is a medium question, but this is some technique that not often that you will use. I don't know, because I don't think a lot of people ask question require this. So, but so yeah, so I think this is a basic thing that you need to learn for the immutable. For the mutable, there are two ways to solve this. So if you are interested, you can still learn those. So one is called segment tree, and the explanation is pretty good. I actually learned it from here. And then the other one is called binary index tree. Do they? Yeah. Do they have the binary index tree in here? No? Okay. But if you check the discussion, there will be a binary index tree solution in here, I think. Yeah. There are 21 people doing it with binary index tree. Yeah. So, but so you might not need to learn this, the mutable one, but I think you definitely need to know the immutable one and how to solve this kind of question. Yeah. So I guess that's it, right? Let's see our submission, not this one. Let's see our submission. Because I think that, yeah, just like you said, the time complexity, after you build the initial one, it will be O of n. And because this is such a basic question, I think almost everybody's time and space are the same, because I guess everybody is using the same technique to solve this question. I bet there are no other people using different technique. Okay, so that's today's question. Hopefully for the rest of the month I won't use any time travel ticket, because I can use only 3 per month, and I already used all of them. 2 for the hard question, and the other one I wasted on a easy question. So from now on till the end of the month, I cannot miss any one of the daily question. So yeah, I will try to stream earlier so that I won't encounter any issue. Okay, so that will be today's daily question. Tomorrow is, oh, tomorrow is not Friday yet. Okay. Hey, no. Do we already have 7 of the questions? 1, 2, 3, 4, 5, 6, 7. Okay, I forgot which one is the day one. So day one is Saturday. Okay, okay, okay. So we are not going to have two questions yet. So okay. So tomorrow there might be still only one question. So then I feel better. And I will see you tomorrow again. Similar time. Okay? Okay, that's today's daily question. Thank you for watching. Bye bye.